we're going to do two examples of the type 1 improper integrals. Those are the ones where one of the limits is going to be either positive infinity or negative infinity on our definite integral. The first one, we're going to try to evaluate this integral, or at least determine if it converges or diverges with the integral from 1 to infinity of 1 over x. The first thing we need to do here is get rid of the infinity in my upper limit. So how do I do that? Write it as a limit. So we're going to rewrite it as the limit as t approaches infinity of the integral from 1 to t of 1 over x with respect to x. Now, since I've done that, I can evaluate this part right here. I'm going to forget about that limit. I'm going to forget about what the value of t is, and I'm just going to evaluate that. So I'm going to do that off to the side, and then I'll come back up here and we'll evaluate the limit. So what is an antiderivative of 1 over x? Natural log of the absolute value of x. And before I go any further, let's talk about whether these absolute values are necessary. What kind of numbers are we dealing with on this integral? We're starting at 1, we're going to infinity, so every number is positive. Since every number we're dealing with is positive, do we need the absolute values? No, I'm going to just get rid of that, and that's going to simplify things for us. So we have the antiderivative is the natural log of x, and we're going to evaluate that from 1 to t. So what do we get here? Natural log of t minus natural log of 1. What is the natural log of 1? What's the natural log of 1? That's 0. So we just get the natural log of t, right? So what we did here is we said this integral, this definite integral, is equal to this. So now I can come back up here and rewrite the problem, and now we're trying to find the limit as t approaches infinity of the natural log of t. Because remember, this integral here is equal to the natural log of t. Well, what happens as t approaches infinity to the natural log? It is infinite. So can we evaluate this integral? Or is this a finite area? No. What this is saying, first of all, this diverges, and that's the way we will respond to this type of situation. But what it's saying is the function 1 over x, the area under the function 1 over x, even though this area is getting smaller and smaller and smaller, it is going to be an infinite area. Meaning that if I say I want that area to be a million, I can figure out some t value here to make that area a million. It's going to be a really big t value, but I can make that area as big as I want it to be by going out far enough on the x-axis. This example looks really similar, and a lot of times in calculus when we see similar examples, we might think that we're going to get similar results. So this function right here actually looks a lot like the 1 over x function. On the left side, it's going to be positive instead of negative, but it looks a lot like it still. It's going to be something like that. And so what we're trying to do here is see if this area here is going to be finite or not. We saw with the 1 over x function that it is infinite. Let's see if that's the case here. So the first thing we need to do is rewrite this as a limit. So we're going to take the limit as t approaches infinity of the integral from 1 to t, 1 over, and actually I'm going to rewrite it, x to the negative 2 dx. I just did that so it's easier to evaluate the antiderivative. Again, I'm going to take this part right here, go off to the side and do some computation, and then plug it back in, plug my result back in. So the integral from 1 to t of x to the negative 2 with respect to x is going to be what? What's the antiderivative of x to the negative 2? Yeah, it would be negative x to the negative 1. Probably the simplest way to write it would be that, negative 1 over x. And we want to evaluate that from 1 to t. To t here. Okay, so what do we do? Okay, we get negative 1 over t minus 1. And so I can take this right here and plug it in for that right there.
Is it plus 1?
Probably. Yeah, it should be plus 1. Thanks, Jeremy. We get the limit as t approaches infinity of negative 1 over t plus 1. And what's going to happen here as t approaches infinity? Yeah, this part right here goes to 0. So we get 0 plus 1, which is 1. So this area here, even though it's infinitely long, even though we're going as far as we want out the x-axis, if we go infinitely far, that entire area is going to add up to 1. Kind of crazy, isn't it?